So as we know, the Biden administration just announced a huge $2 trillion infrastructure plan, which also in so many ways is both a climate mitigation and a resilience plan and an ambitious environmental justice initiative. So can you talk to us a little bit about infrastructure vulnerabilities, especially in the context of climate change, sea level rise, flooding risk, etc.? What are these risks? Who is really facing these risks most acutely? And how can tech and specifically the work that you're doing help us build infrastructure resilience?
Yeah, great. Thank you. Wonderful question. Giant question, of course. So way to start it off with the big one. I really appreciate it. Also, thank you to Cody and all of Techstars. Second, it's good to see a lot of peers and cohort folks that we know from our Nature Conservancy Techstars Sustainability Program. Really excited about that. Very happy to be here. I appreciate the question a lot. Of course, at Second Nature Software, we focus on stormwater infrastructure. And we choose to focus on stormwater infrastructure really for three reasons. Firstly, stormwater runoff into our urbans, streams, lakes, bays is the fastest growing source of urban pollution in the United States. Secondly, there's a lot of money being spent annually on stormwater programs in the US. According to the most recent Water Environment Federation or West Stormwater Institute survey, it's about $42 billion a year is spent programmatically in the US on stormwater infrastructure and programs. And then thirdly, it's a regulated requirement for all municipalities to have a stormwater program in place and attempt to do a better job at reducing the amount of pollution that reaches their urban waters. So to kind of get into your question a little bit, the baseline stormwater infrastructure risk in the US is high, and it's high because of the simple fact that there's a lot of it. There's about $400 billion worth of infrastructure in the ground across the country. Much of it is old, and a lot of it is beyond its service life. Some of it is decades beyond, even half a century beyond its service life. So, of course, that risk increases for that infrastructure when environmental factors associated with climate risk are weighed in. The greater frequency of severe rain events, drought, wildfire impact, all of these things have an influence on the natural hydrology of the environment. So stormwater flow and volume increases, and it brings sediment and pollution with it as it goes through our urban areas where people live. The frequency of flood events is increasing. According to FEMA, pretty much every county in the US is impacted by a flood event over the past 25 years. So to translate that into the real world, what that means at the local level is that urban floods often are occurring more frequently, and they're often doing that in areas with the highest amount of impervious surface. So many of those areas of our communities with high impervious surface are areas where there's a lot of pavement, and they happen to be socially and economically disadvantaged portions of our communities. And so what we see at a national level then is FEMA, for example, they're spending about $3 billion a year on their annual flood risk insurance. So very real impacts at the local level, at the federal level. And so what we see is technology can play a number of roles in this equation. From Second Nature's perspective and a software perspective, working with municipalities, what we're finding is the cloud can play a central role in and of itself. At all levels of government, we see a digital transformation occurring, the cloud moving in, really embracing this kind of software as a service base of technology that really allows us to start centralizing information, centralizing data, in the case of stormwater infrastructure related to stormwater assets and programmatic information. Secondly, stormwater programs and the infrastructure that's under the ground in our municipalities is obviously very distributed. So we can use geographic information systems to gather and understand geographic related information about those assets, like where they're located, what their condition is, how they're performing relative to their design specification. Are they capturing the volume of water that we designed them to? Are they reducing the amount of pollution or sediment that we designed them to do? And then lastly, that provides an excellent platform for really inserting in science-driven information making tools. And this is what Second Nature is really grabbing onto, is the ability to bring best-in-class stormwater-related methods and models and use all of that cloud-based data, that GIS-based data, and inform it with science so that the people who are running these programs on a daily, weekly, annual basis, so at the watershed level, planners are able to make more informed decisions around where are the best places in our communities to make investments. So tying that back to the idea that the Biden administration is investing massively, really once in a lifetime level investment in new infrastructure. Much of that's going to take the form of transportation. Of course, our roads, our highways, our freeways are very important conduits for stormwater. We can all drive around and we can see large basins at the side of a freeway or something like that. They're also focusing how that money gets spent to really try and get the best bang for the buck, or a return on investment, so that those dollars are going to build green infrastructure, stormwater infrastructure, in areas where there's an opportunity to reduce flood risk, or where there's an opportunity to potentially create green space, and do that in a way that takes into account social economic factors as well as hydrology, stormwater, flood risk factors. These are the types of things then that really start to move the needle from an environmental justice standpoint, potentially, and and ultimately start building more resilient communities, more healthy communities.